And now in this lecture we will find out the length of line segment X using two different methods. In the drawing we have quadrilateral ABCD, side AB equals to 5 units, side AD equals to 3 units, side DC equals to 6 units, angle ADC equals to 90 degrees, angle DCB equals to angle ABC equals to theta, and we want to find out the length of line segment BC that is equal to X. Okay, so we start with the first method, and we will extend side BA and side CD of quadrilateral ABCD by a straight line until they intersect with each other. And we will define the intersection point between the extended side AB and the extended side CD as E. So here the intersection point or the touching point of side BA, the extended side BA and the extended side CD is defined as E. So we created here triangle EBC. In triangle EBC we have two equal angles. Those two angles are both equal to theta, therefore they are equal to each other. And we have rule number 1. According to rule number 1, in front of equal angles in the triangle there are equal sides. I write it down. In front of equal angles in the triangle there are equal sides. I will read rule number 1 again. According to rule number 1, in front of equal angles in the triangle there are equal sides. So here we will focus on triangle EBC. In triangle EBC, angle EBC, this angle is equal to this angle that is actually angle ECB, and both angles are equal to theta. I'll repeat again. In triangle ECB we have angle EBC that is equal to angle EBC and angle EBC that is equal to angle ECB, and both angles are equal to theta. Therefore, according to rule number 1, in front of those two equal angles there are equal sides. That is to say, EB equals to EC. According to rule number 1, in triangle ECB, EB is equal to EC. Again, side EB equals to side EC because those two sides are located in front of those two equal angles. Therefore, they are equal to each other. According to rule number 1, of course. But if EB equals to 5 plus AE, again, side EB equals to 5 plus AE, So we substitute EB by 5 plus AE, while EC, side EC equals to 6 plus ED. So we substitute side EC by 6 plus ED. So here we will subtract 5 from this equation, and we will get that AE equals to 1 plus ED. Okay? According to this equation number 1, AE equals to 1 plus ED. AE equals to 1 plus ED. So we define ED as A. Here, ED is equal to A according to our definition. Now we substitute ED by A in equation number 1. So here we get that AE according to equation number 1 equals to 1 plus ED, and we will substitute ED by A, and we got that actually AE equals to 1 plus A. So according to equation number 1, AE equals to 1 plus A. Here AE equals to 1 plus A. Okay? So here actually, before the construction, we had a quadrilateral ABCD. In quadrilateral ABCD, line segment DC is one side of quadrilateral ABCD. Again, line segment DC is one side of quadrilateral ABCD, and as a side of a quadrilateral, it is absolutely a straight line. So CD is a straight line, and then when we extended the straight line CD by a straight line, we got line segment CE, that it must be also a straight line. Why? Because when you extend a straight line by a straight line, the result must be a straight line. So you can write down that EC is a straight line, because when you extend a straight line by a straight line, the result must be a straight line. So EC is a straight line. We know that line segment EC is a straight line. And we have rule number 2. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. The sum of the angles on one side of a straight line is equal to 180 degrees. I will read rule number 2 again. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. According to our conclusion, EC is a straight line, so if we focus on this side of the straight line EC at point D, then the sum of the angles here must be equal to 180 degrees. So which angles we have at point D? which angles we have at this side of the straight line EC at point D. We have here 90 degrees. And we have also this angle that is actually angle EDA, angle EDA. So the sum of those two angles must be equal to 180 degrees according to rule number 2, of course. So here we will subtract 90 degrees from this equation. And we'll get that angle EDA, the missing angle, equals to 180 degrees minus 90 degrees, it is 90 degrees. This angle, angle EDA, equals to 90 degrees. And if angle EDA equals to 90 degrees, then triangle EDA is a right triangle. The right EDA, triangle EDA, the green triangle, that is triangle EDA, is a right triangle because angle EDA equals to 90 degrees. So we will implement the Pythagoras theorem in the right green triangle, triangle EDA. According to the Pythagoras theorem, in the right green triangle, triangle EDA, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Here, by PT, is the relation for Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. So here, the hypotenuse is AE. So the square of the hypotenuse is AE squared. This is equation number 2. AE squared, it is equal to the sum of the squares of the perpendiculars, that is to say it is equal to AD squared plus ED squared. Okay, according to the Pythagoras theorem on the right green triangle EDA, AE squared equals to AD squared plus ED squared. ED equals to 1 plus A, so we substitute AE equals to 1 plus A, so we substitute AE by 1 plus A. If A equals to 1 plus A squared equals to 1 plus A squared, and it is equal to AD squared. If AD equals to 3, so AD squared is 3 squared, that is 9, plus ED squared. ED equals to A, so ED squared is A squared. So in conclusion, according to equation number 2, we found out that 1 plus A squared equals to 9 plus A squared. Here we will open the brackets on this side of equation number 2, and we will get that according to equation number 2, 1 plus A squared equals to 1 squared, that is 1, plus A squared plus 2A. And it is equal to 9 plus A squared. Here we have A squared on both sides of equation number 2. So A squared will get cancelled, and we left only, according to equation number 2, 1 plus 2A equals to 9. Here we subtract 1 from this equation, equation number 2. And we get that according to equation number 2, 2a equals to 9 minus 1 is 8. Here we divide this equation number 2 by 2, and we get that 2a over a is a equals to 8 over 4, that is 8 over 2. A equals to 8 over 2, that is 4. So we found out that A equals to 4 units, and A plus 1 is 4 plus 1, that is 5 units. So in the next step we will define angle AED. This angle is angle alpha. So in the right green triangle, triangle AED, we know that cosine alpha equals to ED over AE. ED equals to 4 units, AE equals to 5 units. So in conclusion, we found out that cosine alpha equals to 4 over 5. Cosine alpha equals to 4 over 5. In the next step, I will present to you the law of cosines, and we will implement the law of cosines in this triangle, triangle ABC. Okay, so what is the law of cosines? The law of cosines is true in any triangle. So if we have a triangle ABC, that could be any triangle, and this is triangle ABC. And we know that side AB of triangle ABC equals to A units in its length, side AC equals to B units in its length, and side BC equals to C units in its length, and the angle between side AB and side AC is alpha. Then according to the law of cosines, we will get that C squared equals to A squared plus B squared minus 2 times A times B times cosine alpha. I'll repeat again. According to the law of cosines, C squared equals to A squared plus B squared minus 2 times AB times cosine alpha. Okay, so we can implement all the law of cosines in our triangle, triangle EBC. So in triangle EBC, here EB is A, EC is B, and BC is C, that is X. And this is of course angle alpha. So we get that C squared is BC squared that is actually x, equals to a squared. A squared is EB squared plus B squared. B squared is EC squared minus 2 times EB times EC times cosine alpha. So actually equation number 3, this equation is the implementation of the law of cosines in triangle ABC. BC equals to x, according to what is given as the question. So BC squared is x squared equals to EB squared. Here EB equals to 5 plus 5, that is 10. So EB equals to 10. Here EC, side EC of triangle EBC equals to 4 plus 6, that is also 10. So EC also equals to 10. So here we get that BC squared equals to, that is x squared, equals to EB squared. EB is 10, so EB squared is 10 squared, that is 100, plus EC squared. EC equals to 10, so EC squared is 10 squared, that is also 100, minus 2 times EB is 10, times EC, it is also 10, times cosine alpha. And we have already found out that cosine alpha equals to 4 over 5. Here I will remind to you that we have already found out that cosine alpha equals to 4 over 5. So we can substitute cosine alpha in this equation number 3 by 4 over 5. Here cosine alpha equals to 4 over 5. So here, according to equation number 3, x squared equals to 100 plus 100 is 200, minus 10 times 10 is 100, and 100 minus 2 is minus 200. This is minus 200 times 4 over 5. So in conclusion, according to equation number 3, we got that x squared equals to 200 minus 200 over 5. Minus 200 times 4 over 5. Here 200, so here we have x squared, according to equation number 3, x squared equals to 200 minus 200 over 5 is minus 40. So we have here minus 40 times 4. So in conclusion, we found out that x squared equals to 200 minus 40 times 4, minus 40 times 4 is minus 100. So according to equation number 3, we got that x squared equals to 200 minus 40 times 4 is minus 160. And 200 minus 160 is 40. So in conclusion, we found out that x squared, according to equation number 3, equals to 40. Here we take out of this equation number 3, and we get that according to equation number 3, x equals to the square root of 40. And 40 is 4 times 10, so we substitute 40 by 4 times 10. The square root of 4 is 2, so in conclusion, we found out that x equals to 2 times square root of 10 units, so in terms of numbers, it is equal to 6.32 units. Okay, so we finished with the first method. Here, the value that we are looking for, that is actually x that is equal to BC, it is equal to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. Okay, so we finished with the first method. In the next step, I will present to you how to find out the length of this line segment BC that is equal to x according to the second method. In the second method, we will do another construction. From point A, we will draw a straight line to DC in such a way that the straight line will be parallel to BC. So here we will have this straight line. We define the touching point of the straight line with TC as E. So I'll repeat again that we drew the straight line AE in such a way that it will be parallel to BC. I'll write it down that AE, the green line segment, is parallel to BC according to our construction. In the next step, from point E, we will draw a straight line on BC in such a way that the straight line that we will draw will be parallel to AB. Okay? We will define the touching point of the straight line from point E and BC as F. I will repeat again that we draw the straight line EF in such a way that it will be parallel to AB. So I will write it down. AF is parallel to AEF. AEF, the straight line that we do is EF, is parallel to AB according to our construction. Okay? So here, quadrilateral AEBF is a parallelogram. I write it down. Quadrilateral AEBF is a parallelogram. Why quadrilateral ABF is a parallelogram? Because of the fact that it has two couples of sides that are parallel to each other. Here AE is parallel to BF and AB is parallel to EF. And this is exactly the definition of a parallelogram. Any quadrilateral that has two couples of sides that are parallel to each other, it is defined as a parallelogram. Therefore, quadrilateral AEBF that has two couples of sides that are parallel to each other, it is a parallelogram. Okay? the next step I will present to you a new rule that is actually rule number 3. According to rule number 3, corresponding angles between parallel lines are equal to each other. Corresponding angles between parallel lines are equal to each other. So I repeat on rule number 3 again. According to rule number 3, corresponding angles between parallel lines are equal to each other. So according to our construction, AB is parallel to EF. AB is parallel to EF according to our construction. So actually those two angles are defined as corresponding angles, and they are located between the parallel lines AB and EF, therefore they are equal to each other according to rule number 3. So you can write down that angle ABC, this angle, is equal to this angle that is actually angle EFC. According to rule number 3. I repeat again, angle ABC equals to angle EFC according to rule number 3, because those two angles are located between the parallel lines AB and EF, therefore they are equal to each other according to rule number 3. But according to what is given us in the question, angle ABC equals to theta. So you can write down that angle ABC equals to theta, and from this equation theta equals to angle ABC equals to angle EFC, we will derive that angle EFC is also equals to theta. Okay, angle EFC equals to theta. So you can write here that angle EFC, this angle equals to theta. Likewise, according to our construction, AE is parallel to BF. I'll write it down. AE is parallel to BF. Again, AB is parallel to, again, actually here we have AE, AB over AE is parallel to BC. Again, AE is parallel to BC. According to our construction, AE is parallel to BC. According to our construction, Okay? So, therefore, according to rule number 3, those two angles that are defined as corresponding angles and are located between the parallel lines AE and BC will be equal to each other. That is to say, angle DEC, this angle, will be equal to this angle that is actually angle ECB or DCB. I repeat again, because of the fact that AE is parallel to BC according to our construction, then we'll conclude from it that angle DEC is equal to angle DCB according to rule number 3 because of the fact that those two angles are located between the parallel lines AE and BC, therefore they are equal to each other. Okay, those two angles are located between the parallel lines AE and BC, therefore they are equal to each other. But this angle, angle DCB equals to theta according to what is given as the question. Okay, I write it again, angle DCB equals to angle DEC according to rule number 3, and angle DCB equals to theta according to what is given as the question. So from this equation, theta equals to angle DCB equals to angle DEC, we will derive that angle DEC is also equals to theta. Okay, angle DEC equals to theta. So here we'll focus in the next step. I will present to you a new rule that is actually rule number 4. According to rule number 4, the opposite sides of a parallelogram are equal to each other. I write it down. The opposite sides of a parallelogram are equal to each other. So I read rule number 4 again. According to rule number 4, the opposite sides of a parallelogram are equal to each other. So we focus on our parallelogram AEBF. According to rule number 4, AB equals to EF. And EFP is a variation of parallelogram, so in parallelogram AEBF, according to rule number 4, we get that AB equals to EF. AB equals to EF according to rule number 4, that says that the opposite sides of a parallelogram are equal to each other. but AB equals to 5 units according to what is given us in the question. So we can write here that AB equals to 5, and from this equation 5 equals to AB equals to EF, we will derive that EF is also equals to 5. Here EF is also equals to 5. Now we will focus on the right on triangle EFC. In triangle EFC, in this triangle EFC, those two angles are equal to each other. So I write it down. In triangle EFC, angle EFC is equal to this angle ECF. And both those two angles are equal to theta according to what is given us in the question. Actually, this angle equals to theta according to rule number 3, but okay, this angle equals to theta according to what is given in the question. So, but here, because of the fact that in triangle EFC those two angles are equal to each other, we will conclude from it that according to rule number 1, that in front of equal angles in the triangle there are equal sides, we will conclude from it that EF equals to EC. Okay, we conclude from it that EF equals to EC according to rule number 1, that in front of equal angles in the triangle there are equal sides. But EF equals to 5 units according to what we already found out. Here EF equals to 5 units. And from this equation 5 equals to EF equals to EC, we will derive that EC is also equals to 5 units. EC equals to 5 units. So you can write here that EC equals to 5 units. So here, you know that EC equals to 5 units, so what is the length of line segment DE? From the drawing, it is very easy to see that the length of line segment DE equals to DC minus EC again. DC minus EC equals to DE. I'll write it down. DE equals to DC minus EC. So here DE equals to DC, that is 6 units according to what is given us in the question, minus EC, that we have already found out that it is equal to 5 units. So it is 6 minus 5, that is 1. So we found out that DE equals to 1 unit. DE equals to 1 unit. You can write here that DE equals to 1 unit. Now we'll focus on the right triangle ADE. On the right great triangle ADE, and we will implement the Pythagoras theorem on the right great triangle ADE. So here, in the right great triangle ADE, by PT, that is the abbreviation for Pythagoras theorem, we will get that the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say AE squared this will be equation number 1, AE squared AE squared equals to AD squared plus DE squared. I repeat again, in the right triangle ADE, according to the Pythagoras theorem, AE squared equals to AD squared plus DE squared. So AE squared equals to AD squared. AD equals to 3 according to what is given us in the question, so AD squared is 3 squared, that is 9, plus DE squared. DE equals to 1, so DE squared is 1 squared, that is 1. So in conclusion, we found out that according to equation number 1, AE squared equals to 9 plus 1, that is 10. Here we take out of this equation, equation number 1, and we get that according to equation number 1, AE equals to the square root of 10 units. AE equals to the square root of 10 units. So we can write here that AE equals to the square root of 10 units. And according to rule number 4, that the opposite sides of a parallelogram are equal to each other, we get that AE equals to BF. AE equals to BF, according to rule number 4, that says that the opposite sides of a parallelogram are equal to each other. AE is equal to BF, according to rule number 4, that the opposite sides of a parallelogram are equal to each other. But we just right now found out that A equals to the square root of 10 units. A equals to the square root of 10 units, so from this equation, square root of 10 units equals to AE equals to BF, we will derive that BF is also equals to the square root of 10 units. Okay, BF is also equals to the square root of 10 units. So we can write here that BF equals to the square root of 10 units. Now it is very easy to find out the length of FC. Here FC equals to BC minus BF. Again, BC minus BF equals to FC. So write it down. FC equals to BC minus BF. We see it easily from the drawing. So actually FC equals to BC. BC equals to X according to what is given as the question. And we just right now found out that BF equals to the square root of 10 units. So in conclusion, we found out that FC equals to X minus square root of 10 units. Okay, so we can write here that FC equals to x minus square root of 10 units Actually, we'll focus on triangle EFC. In triangle EFC, we know that side FE equals to side EC equals to 5 units, therefore triangle EFC is an isosceles triangle. I'll write it down. Triangle EFC is an isosceles triangle because of the fact that side EF equals to side EC. EF equals to EC equals to 5 units. For that reason, it is an isosceles triangle. And in addition, here FC is the base of the isosceles triangle, triangle EFC. FC, side FC is the base of the isosceles triangle, triangle EFC. Okay? And we'll do a construction here. From point E, we'll go perpendicular on FC. We will define the touching point of the perpendicular from point E and FC as F, as M. I'll repeat again. We will define the touching point of the perpendicular from point E and FC as M. So here, this angle equals to 90 degrees, and this angle equals to 90 degrees according to our construction. Because EM is perpendicular to FC, this angle equals to 90 degrees, and this angle also equals to 90 degrees. So, what is the definition of EM? EM is perpendicular to FC. And this is exactly the definition of height. So, EM is the height to the base FC. So EM is the height to the base, and the base is FC, to the base of the isosceles triangle, triangle EFC. I will write it down. EM is the height to the base and the base itself is FC. So in the next step I will present to you rule number 5. According to rule number 5, the height to the base in an isosceles triangle bisect the base. So I read rule number 5 again. According to rule number 5, the height to the base in an isosceles triangle bisect the base. So here we have the isosceles triangle FEC, and according to rule number 5, the height EM to the base FC bisects the base FC. That is to say, it divides it into two equal parts. So according to rule number 5, FM equals to MC. According to rule number 5, FM equals to MC. According to rule number 5, of course. And according to rule number 5, the height to the base in an isosceles triangle bisects the base. What is the meaning? It bisects the base. It means the meaning of the sentence, it bisects the base. It means that it divides it into two equal parts. If it divides the base FC into two equal parts, it means that each part will be equal to FC over 2. So FM equals to FC over 2, and MC will be also equal to FC over 2, because it bisects the base into two equal parts. That is to say, it divides it into two equal parts. So each part must be equal to FC over 2. So according to rule number 5, Fm equals to Fc over 2, and Mc is also equals to Fc over 2. So you can write down that Fc over 2 equals to Fm equals to Mc. Or in other words, Mc is equal to Fc over 2. Fc over 2. But MC equals to x over square root of 10. FC equals to x over square root, FC equals to x minus square root of 10. And if we divide it by 2, we get the value of MC. So here, MC equals to x minus square root of 10 over 2 according to rule number 5. Very simple. MC equals to FC over 2, but FC over 2 equals to x minus square root of 10, that is FC over 2. Okay, so in conclusion, here MC equals to x minus square root of 10 over 2, according to rule number 5. So in the next step, we will prove that the right big triangle EMC is similar to the right small green triangle ADE. Okay? We will prove that those two green right triangles are similar to each other. So why those two green right triangles are similar to each other? So write it down. We will prove the triangle, the right small triangle AED is similar to the right big triangle EFC. The two right triangles are similar to each other. First of all, in triangle EMC, in this triangle EMC, this angle equals to 90 degrees. This angle equals to theta. So this angle must be equal to 90 degrees minus theta in order to complete the sum of the angles 280 degrees in this right big green triangle. This angle must be equal to 90 degrees minus theta. And for the same reason, in the right triangle AED, this angle equals to 90 degrees, this angle equals to theta. So this angle must be equal to 90 degrees minus theta for the same reason. So actually, those two angles are both equal to each other. Those two angles are equal to each other because of the fact that they are both equal to 90 degrees minus theta. So you can write down that angle DAE equals to angle MEC, and both angles are equal to 90 degrees minus theta. I'll repeat again. Angle DAE equals to angle MEC equals, both angles are equal to 90 degrees minus theta. In addition, we have those two angles that are both equal to theta. Therefore, they are equal to each other. So angle DEA in this small green triangle is equal to this angle that is actually angle MEC. And both angles are equal to 90 degrees minus theta. Therefore, they are equal to each other. I'll repeat again. Angle DEA equals to angle MEC, and both angles are equal to 90 degrees minus theta. And finally, those two angles are both equal to 90 degrees, therefore they are equal to each other. So we can write down that angle EDA, this angle, is equal to this angle that is actually angle EMC, and both angles are equal to 90 degrees. I'll repeat again, angle EDA equals to angle EMC, and both angles are equal to 90 degrees. So we actually proved that all the angles of triangle AED can point to all the angles of triangle EMC, therefore those two right green triangles are similar to each other according to angle similarity rule. So I will write it down. So triangle AED is similar, this is the sign of similar to triangle EMC. According to angle similarity rule. And from the fact that those two right green triangles are similar to each other, we will conclude hence that AE over EC is equal to DE over MC. I repeat again, from the fact that the green right triangle AED is similar to the green right triangle EMC, we will conclude that AE over EC equals to DE over MC. AE equals to square root of 10 units, so we substitute AE by square root of 10. EC equals to 5 units, we'll substitute EC by 5. And it is equal to DE equals to 1, so we'll substitute DE by 1 over MC. MC equals to x minus square root of 10 over 2, so we'll substitute MC by x minus square root of 10 over 2. So in conclusion, we found out that according to equation number 2, square root of 10 over 5 equals to 1 over x minus square root of 10 over 2. Here we will move 2 to the numerator and x minus square root of 10 to the denominator, and we will get that according to equation number 2, square root of 10 over 5 equals to 2 over x minus square root of 10. Here we will cross multiply this equation, equation number 2, and we will get that according to equation number 2, square root of 10 times x minus square root of 10 equals to 5 times 2, that is 10. We know that tan equals to square root of 10 times square root of 10, so we substitute 10 by square root of 10 times square root of 10, or we can write here that it is equals to square root of 10 times square root of 10, and now we will divide this equation by square root of 10, and we will get that according to equation number 2, here we'll divide this side of equation number 2 by square root of 10. Square root of 10 times square root of 10 is 1. So here what is left in this side of equation number 2 is only x minus square root of 10. And here square root of 10 times square root of 10 or over square root of 10 is square root of 10. So here we will add square root of 10 to this equation, equation number 2, and we will get that according to equation number 2, x equals to square root of 10 plus square root of 10 is 2 times square root of 10 units, or in terms of numbers it is equal to 6.32 units. I'll repeat again, we found out that the length of line segment x equals to either 2 times square root of 10 units, or in terms of numbers it is equal to 6.32 units. Here x equals to 6.32 units, so can present it also as 2 times square root of 10 units. This is the answer to the question. In the next step, I will summarize the lecture. We'll start with the first method. So I repeat on the question, we have here for the quadrangle ABCD, side AB equals to 5 units, side AD equals to 3, DC equals to 6, angle ADC, this angle equals to 90 degrees, angle ABC equals to angle DCB equals to theta, and we want to find out the length of side BC that is actually equals to x. So in the first step we did the construction. We extended side BA and side CD until they intersect with each other at point E. Point E is the intersection point of the extended BA and the extended CD. So created here triangle EBC. In triangle EBC we have two angles that are equal to each other, they are both equal to theta. Okay? Then I presented to you rule number 1. According to rule number 1, in front of equal angles in the triangle there are equal sides. So here in triangle EBC, you know that angle EBC equals to angle ECB equals to theta. According to what is given as the question, angle EBC equals to angle ECB equals to theta. Therefore, we can conclude from it, according to question number 1, that EB equals to EC. Why? Because in front of those two equal angles, there are two equal sides. That is to say, EB equals to EC in triangle UFC. EB equals to EC according to rule number 1. EB equals to 5 plus, EB equals to 5 plus AE. Okay, EB equals to 5 plus AE, and EC equals to 6 plus ED. Again, EB equals to 5 plus AE and EC equals to 6 plus ED. Here we subtracted 5 from this equation, equation number 1, and we found out that according to equation number 1, AE equals to 1 plus ED. Okay, and then we defined ED as A. So here ED equals to A according to our definition. Therefore, according to equation number 1, we can see that AE equals to 1 plus ED. That is to say, I repeat again, we defined ED as A, and therefore according to equation number 1, we found out that A equals to 1 plus A. Here AE equals to 1 plus A according to equation number 1, AE equals to 1 plus A. Okay? So here, before we did the construction, we had the quadrilateral ABCD, and side CD is one side of quadrilateral ABCD, therefore it is absolutely a straight line. CD, it is one side of quadrilateral ABCD, therefore it is a straight line. And then when we extended the straight line CD by a straight line, the result must be a straight line, because when you extend the straight line by a straight line, the result must be a straight line. So the result, that is CE, must be a straight line. So CE or EC is a straight line. Okay? Then we have rule number 2. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. So here, if we focus on this side of the straight line EC at point D, then the sum of the angles here must be equal to 180 degrees. So which angles we have at point D on this side of the straight line EC? We have here 90 degrees, and then again EDA. Okay, so here 90 degrees plus angle EDA in total they must be equal to 180 degrees, according to rule number 2, that the sum of the angles on one side of a straight line is equal to 180 degrees. Here we subtracted 90 degrees from this equation, and we found out that the missing angle EDA equals to 90 degrees. This angle is a right angle, therefore the green triangle, triangle EDA, is a right triangle. Okay? So, in the green triangle EDA, we can implement the Pythagoras theorem because it is a right triangle. So in the right triangle, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AE square equals to AD square plus ED square. So in the right green triangle, triangle EDA, according to the Pythagoras theorem, AE square equals to AD square plus ED square. AE equals to 1 plus A, so A square is 1 plus A square equals to AD square. Here AD equals to 3, so AD square is 3 squared, that is 9. plus ED squared. ED is A, so ED squared is A squared. So in conclusion, found out that according to equation number 2, 1 plus A squared equals to 9 plus A squared. We open the brackets on this side of equation number 2, and we found out that 1 plus A squared equals to 1 squared, that is 1, plus A squared, that is A squared, plus 2A. And in the other side of equation number 1, we have 9 plus A squared. Here we have A squared on both sides of equation number 2, so A squared will get cancelled, and we left only with 1 that is equal to 1 plus 2A that is equal to 9. We subtracted 1 from this equation, equation number 2, and we got that 2A equals to 9 minus 1, that is 8. So 2A equals to 8. According to equation number 2, we divided equation number 2 by 4, and we got that A equals to 8 over 4, 8 over 2. We divided equation number 2 by 2, and we got that 2A equals to 2A over 2 is A, and 8 over 2 is 4. So in conclusion, we found out that A equals to 4 units. Here, A equals to 4 units, and A plus 1 is 5. So in the right green triangle, we defined angle AED as alpha. So in this green right triangle, we know that cosine alpha equals to ED over AE. Cosine alpha equals to ED over AE. ED equals to 4. A equals to 5. So in conclusion, we found out that cosine alpha equals to 4 over 5. Then I presented to you the law of cosines, and we implemented the law of cosines in the right big triangle ABC. In the isosceles triangle ABC. The law of cosines is true in any triangle. So what is the law of cosines? Here, if we have triangle ABC, that could be any triangle. Side AB equals to A units is left, side AC equals to B units, side BC equals to C units. Then, according to the law of cosines, C squared equals to A squared plus B squared minus 2 times AB times cosine alpha. And this equation is true in any triangle. So we can implement the law of cosines in our triangle EBC. This is angle alpha, EB equals to A, EC equals to B, and BC equals to C. Okay? And here we know that EB equals to 5 plus 5, that is 10. EC equals to also 4 plus 6, that is also 10. And we already found out that cosine alpha equals to 4 over 5. Okay? So according to the law of cosines in the right triangle, in the isosceles triangle ABC, we get that BC squared equals to EB squared plus EC squared minus 2 times EB times EC times cosine alpha. Cosine alpha equals to 4 over 5, so we substituted cosine alpha by 4 over 5. EB equals to 10, EC equals to 10. EC squared is 10 squared, that is 100. EB squared, it is also 10 squared, that is also equals to 100. And BC equals to X, according to what is given as the question. So BC squared will be equal to X squared. So we substituted BC squared by X squared. So here, according to equation number 3, X squared equals to 100 plus 100 is 200. And here we have minus 2. 10 times 10 is 100, and 100 minus 2 is minus 200. So this expression equals to minus 200 times 4 over 5. So in conclusion, we found out that according to equation number 3, x squared equals to 200 minus 200 times 4 over 5. So x squared equals to 200, and 200 over 5 is 40. So this expression equals to minus 40 times 4. Okay, so in conclusion, we found out that x squared equals to 200 minus 40 times 4. Minus 40 times 4 is minus 160. So in conclusion, we found out that x squared equals to 200 minus 60. 200 minus 60 is 40, so in conclusion we found out that x squared equals to 40. We took a root out of this equation number 3, and we got that x equals to square root of 40. 40 is 4 times 10, and the square root of 4 is 2. So in conclusion we found out that the x, the line segment that we are looking for, it is equal to either 2 times square root of 10 units, or in terms of numbers it is equal to 6.32 units. Here, the length of this line segment BC that is equal to x, it is equal to either 2 times square root of 10 units, or in terms of numbers it is equal to 6.32 units. We finish with the first method. In the next step I will present to you how we found out the length of line segment x according to the second method. In the second method we did another construction. Here, from point A, we draw a straight line on DC in such a way that AE will be perpendicular to BC. Again, AE is parallel to BC. We drew the straight line AE in such a way that AE will be parallel to BC. Again, AE is parallel to BC according to our construction. In the next step, from point E, we draw a straight line on BC in such a way that EF will be parallel to AB. Again, EF is parallel to AB according to our construction. So we created here quadrilateral AEBF. Quadrilateral AEBF is two couples of sides that are parallel to each other. AB is parallel to EF and AE is parallel to BF. Therefore, quadrilateral AEBF is a parallelogram. Because this is the definition of a parallelogram. Any quadrilateral that has two couples of sides that are parallel to each other is defined as a parallelogram. So here we have, then I presented to you rule number 1. According to rule number 1, corresponding angles between parallel lines are equal to each other. So here we have, according to our construction, AB is parallel to EF. Again, AB is parallel to EF according to our construction. Therefore, according to rule number 3, those two angles that are defined as corresponding angles that are located between the parallel lines A, B, and EF will be equal to each other. That is to say, angle ABC will be equal to angle EFC according to rule number 3. Very simple. Angle ABC equals to angle EFC according to rule number 3 because those two angles are defined as corresponding angles and are located between the parallel lines A, B, and EF. Therefore, they must be equal to each other according to rule number 3. Therefore, ABC, angle ABC equals to angle EFC according to rule number 3. But according to what is given as the question, angle ABC equals to theta. So we can write here that angle ABC equals to theta, and from this equation, theta equals to angle ABC equals to angle EFC, we will derive that angle EFC is also equals to theta. So we can write here that angle EFC, this angle is also equals to theta. Likewise, according to our construction, AE is parallel to BC. Again, AE is parallel to BC according to our construction. Therefore, according to rule number 3, those two angles that are defined as corresponding angles that are located between the parallel lines AE and BC will be equal to each other. Okay, so here, according to rule number 3, because of the fact that AE is parallel to BC, we will get that angle DEC is equal to angle BCD, according to rule number 3. But angle BCD equals to theta. according to what is given us the question, angle BCD equals to theta. So we can write here that angle BCD equals to theta, and from this equation theta equals to angle BCD equals to angle DEC, we will derive that angle DEC equals to theta. So here, this angle DEC equals to theta. Okay, then I presented to you rule number 4. According to rule number 4, the opposite sides of a parallelogram are equal to each other. So here we have parallelogram AEBF, and according to rule number 4, the opposite sides of this parallelogram are equal to each other. Okay, that is to say, AB is equal to EF, according to rule number 4. AB is equal to EF according to rule number 4. But according to what is given as the question, AB equals to 5. So we can write here that AB equals to 5. And from this equation, 5 equals to AB equals to EF, we will derive that EF is also equals to 5. Here EF is also equals to 5. Okay? Then focus on triangle EFC. In triangle EFC, we have two angles that are equal to each other. They are both equal to theta. Here, in triangle EFC, angle EFC is equal to angle ECF, and they are both equal to theta. Therefore, we can conclude from it that according to rule number 1, side EF equals to side EC. Why? Because in front of equal angles in the triangle, there are equal sides. Those two sides EF and EC that are located in front the equal angles, those two equal angles, they must be also equal to each other. That is to say, EF equals to EC according to rule number 1. But we have already found out that EF equals to 5, so we can write here that EF equals to 5, and from this equation 5 equals to EF equals to EC, we will derive that EC is also equals to 5 units. Here EC equals to 5 units. Now it is very simple to find out the length of the short line segment DE. What is the length of line segment DE? DE equals to DC minus EC. Again, DE equals to DC minus EC. Okay, I repeat again. DE equals to DC minus EC. So DE equals to DC. DC is 6 units minus EC. EC is 5 units. EC is 5 units. So in conclusion, we found out that D equals to 6 minus 5, that is 1. So DE equals to 1 unit. Then we actually implemented the Pythagoras theorem on the green right triangle, triangle ADE. We know that this side D equals to 1, side AD equals to 3, and the only missing side is the hypotenuse AE. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say AE square equals to AD square plus DE square. Okay, in the right triangle ADE, by Pythagoras theorem, AE square equals to AD square plus DE square. So AE square equals to AD square. AD equals to 3 units, so AD square is 3 squared, that is 9, plus DE square. DE equals to 1, so DE square is 1 squared, that is also 1. In conclusion, found out that AE square equals to 9 plus 1, that is 10. So AE square equals to 10 units. We took a root out of this equation number 1, and we got that AE equals to square root of 10 units. Here, AE equals to square root of 10 units. Now, we can implement rule number 4 in parallelogram AEBF. According to rule number 4, the opposite sides of a parallelogram are equal to each other. That is to say, AE equals to BF according to rule number 4. AE equals to BF according to rule number 4. But we just right now found out that A equals to square root of 10 units. So from this equation, square root of 10 units equals to AE equals to BF. We will derive that BF is also equals to square root of 10 units. Okay, BF is also equals to square root of 10 units. Now we know that BF equals to square root of 10 units. BC equals to X. So what is the value of FC? It is very simple to see from the drawing that FC equals to BC minus BF. Again, FC equals to BC minus BF. BC equals to X according to what is given as the question. BF, we just write down, found out that BF equals to square root of 10 units. So BC equals to X and BF equals to square root of 10 units. In conclusion, we found out that FC equals to X minus square root of 10 units. So here we can write down that FC equals to X minus square root of 10 units. Okay? Then we focus on triangle FEC. Triangle FEC is an isosceles triangle because of the fact that FE equals to FC equals to 5 units. Any triangle that has two sides that are equal to each other must be at least an isosceles triangle. So here, triangle EFC is an isosceles triangle because of the fact that EF equals to EC equals to 5 units. And the base of the isosceles triangle EFC, it is FC of course. FC is the base of the isosceles triangle FEC. So here FC is the base of the isosceles triangle EFC. And then we made a construction from point E with group perpendicular on FC. So EM is perpendicular to FC. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. Actually EM is perpendicular to FC. Therefore EM is the height to the base FC because this is exactly the definition of the height. Any line segment that is perpendicular to the base FC is defined as the height. So EM, the line segment that actually exists from the vertex of the triangle and ends at point M and makes 90 degrees with the base FC is defined as the height to the base FC. This angle equals to 90 degrees, this angle equals to 90 degrees, therefore EM is the height to the base FC. Okay, EM is the height to the base FC. EM is the height to the base FC. Then I presented to you rule number 5. According to rule number 5, the height to the base in an isosceles triangle bisects the base. So according to rule number 5, the height EM to the base FC bisects the base. That is to say, the height EM divides the base FC into two equal parts. That is to say, FC equals to MC. It divides this into equal parts. It means that FM equals to MC. FM equals to MC. According to rule number 5, FM equals to MC. But because of the fact that it bisects the base, it means that it divides the base into two equal parts. So if this side FM equals to FC over 2, then this side MC will be also equal to FC over 2. So FM equals to FC over 2 and MC is also equals to FC over 2. So in conclusion, FC over 2 equals to FM equals to MC, according to rule number 5. But FC, we already found out that FC equals to X minus square root of 10. So we will divide FC by 2 and we will get FC over 2. FC over 2 that is equal to MC equals to FC that is X minus square root of 10. And then we will divide it by 2, we will get FC over 2. And it is equal to MC. So in conclusion, MC equals to FC over 2. That is X minus square root of 10 over 2. So here we know that MC equals to X minus square root of 10 over 2. Then we proved that those two right green triangles are similar to each other. First of all, in this green right triangle EMC, this angle equals to 90 degrees, this angle equals to theta, so this angle must be equal to 90 degrees minus theta in order to complete the sum of the angles in this right green triangle, 280 degrees. This angle must be equal to 90 degrees minus theta. Likewise, in the small right green triangle ADE, this angle equals to 90 degrees. This angle equals to theta. Therefore, for the same reason, this angle must be equal to 90 degrees minus theta. So in those two right green triangles, we know that angle DAE equals to angle MEC, and both angles are equal to 90 degrees minus theta, therefore they are equal to each other. In addition, here we have angle, those two angles, they are both equal to theta, therefore they are equal to each other. So angle ECM equals to angle AED equals to theta. Okay? And finally, those two angles are both equal to 90 degrees, therefore they are equal to each other. So all the angles of triangle ADE correspond to all the angles of triangle ADC, therefore triangle ADE is similar to triangle EMC according to angle similarity rule. Okay, triangle AED is similar to triangle EMC according to angle similarity rule. And from the fact that those two right green triangles are similar to each other, we will conclude that AE over EC equals to MD, AE over EC equals to DE over MC. Here AE over EC equals to DE over MC. Again, AE over EC equals to DE over MC. Here AE equals to square root of 10 units. EC equals to 5. DE equals to 1 and MC equals to x minus square root of 10 over 2. Here we moved 2 to the numerator and x minus square root of 10 to the denominator. And we got that according to equation number 2, square root of 10 over 5 equals to 2 over x minus square root of 10. We cross multiplied this equation number 2, and we got that square root of 10 times x minus square root of 10 equals to 10. But 10 is square root of 10 times square root of 10, so we can substitute 10 by square root of 10 by square root of 10 times square root of 10. We did it, and here 10 equals to square root of 10 times square root of 10. Here we divided this equation by square root of 10. So in this side we divided square root of 10 times square root of 10 is 1, so we left only with x minus square root of 10. Here square root of 10 times square root of 10 over square root of 10 is square root of 10. So in conclusion we found out that x minus square root of 10 equals to square root of 10. We added square root of 10 to this equation number 2, and we got that x equals to square root of 10 plus square root of 10 is 2 times square root of 10. So the answer to the question is that x equals to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. So repeat again, the length of this line segment x, it is equal to either 6.32 units, or it is equal to 2 times square root of 10 units. Okay, thank you very much.